Okay, guys, so on today, we are going to be reviewing for the 6 weeks test that you guys are going to have this Friday. Um, Basically, I'm just going to go over some big concepts with you guys, talk about a few things, and then I'm going to let you guys go to kind of do that review sheet yourself. For those of you guys who would like to do that in preparation for the test. Um, and I'm not as I go through this review, I'm not going to be necessarily going in any particular order. I just kind of want to just cut on the bit. I just want to cover the big ideas. Um, so let me go ahead and begin sharing my screen so I can show you guys what's in Schoology. Okay, so if you go to Schoology, you go to the folder for today. So today is Wednesday. Um, if you look in the folder for today, I have a review sheet for the Fort 6 weeks test. And this review sheet um, basically just has several questions on it from both units that we did, the units on impulse and momentum, and the unit on thermodynamics. Okay, let's start with talking about a little bit about thermodynamics. First, I want to review with you guys what is temperature. This is important that you guys know that. What exactly is temperature? Um, and if you guys remember, I showed you guys this short video clip not too long ago describing what temperature is. For the thermodynamics unit, you're going to need to know a lot of concepts. Um, so, so if you guys remember what temperature is, temperature by definition is a measurement of the kinetic energy of the molecules that make a substance. So as we'll see here.
As the temperature inside the jar decreases, the water vapor molecules move more slowly. And as the temperature increases, the water vapor molecules move more quickly.
Okay, so that's something that I need for you guys to know, that temperature just measures the average molecule. Measures the average kinetic energy of the molecules that make a substance. Now, before I move on to talking about conduction, convection, and radiation, there's also one more thing that I want to state here that we talked about, and it's pretty important. What if you have two substances of different temperatures? Like, for example, one substance is hot and the other substance is cold. And you bring those substances in contact with each other. Um, if you do that, what's going to happen in this case? How's energy going to flow? Remember, energy always flows from the hotter substance to the colder substance until the two substances are in thermal equilibrium. This is a basic principle of nature, guys. I need for you guys to know. Basic principle of nature that energy always flows from hot to cold. And the reason why it does that, because when these substances come in contact with each other, they want to be in thermal equilibrium. So you want to get a flow of energy from the hotter substances to the colder substances until these substances reach the exact same temperature. Okay, so just something to keep in mind whenever discussing temperature. Um, I want to move on now to defining conduction, convection, and radiation. Um, so, in order to review conduction, convection, and radiation. I want to show you guys this brief clip that I got from YouTube, but it does a really good job of reviewing conduction, convection, and radiation. So you guys remember, conduction is whenever there's basically all three of these methods talk about how energy transfers. Conduction deals with energy transfer whenever two objects are directly touching each other. Okay. Convection deals with basically like heat currents in gases and liquids. So you get these convection currents where warm air rises and cold air sinks. And that is convection. And then radiation is energy transfer in the form of electromagnetic waves. So let me show you guys this video clip. It's a rap song that really sums up conduction, convection, and radiation, which I'm going to also put this clip in Schoology as well, so that you guys can watch it if you want, just to review a few things.
There are three ways that he could travel, but it could travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that he could travel, but it could travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. First things first, let's discuss heat, what it is before you pay for it to warm your feet. Heat is the energy that flows when atoms and molecules move. It diffuses out towards coolness. Temperature is the measurement of the average motion of these atoms and molecules in the atmosphere. So there you have it. Now the first way of transportation of heat energy is radiation, like sound waves from your radio stations filling the empty space around you. Your radiator warms you, but don't start a fire now, I warned you. Heat is going through radiation from the sun before it burns you. From 93 million miles away, to re-radiate this heat is what the earth does for you. This is survival, what this heat is going through before it rises to the sky and it's gone. So there are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Conduction, the second method on my list. You can feel it like a hot pot in your fist with the handle gripped. I bet you'd rather grab a candle lit, cause it's heat through conduction that causes this. Atoms and matter in a fixed position vibrate when heated like a pan in the kitchen. Transmit the heat energy to atoms next to them that are cooler than they are, to cause equilibrium. To even out the temperature, the heat has to travel up the spoon in your tea in the morning with your bagel. It might burn your hand, but just learn the land of conduction, heat energy, until you understand. The earth gains little from conduction. It's mostly radiation that helps us function and keeps us warm. It's just another way for heat to move. But now let's move on to method 3 to prove. There are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Convection is the movement of heat in liquids and gases to even out the temperature fastest. This process is called diffusion. It's a flow of particles cold and hot in a fluid. If you're not listening, then stop what you're doing, cause this is the final mode that heat can move in. And this affects you every day. It's the breeze at your back and the wind at your face. When heat reaches the earth, it rises at a rate with the air in the place, and it moves up till it cools. Trillions of molecules together make up the weather that we see on the news. It's how they measure the pressure of the air and the temperature, but convection is how it got there in the atmosphere. So don't be scared. Heat moves in three ways, so we made things clear. It's like there are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection.
All right. So I thought that Rap did a really good job of just kind of reviewing those three methods of energy transfer, just kind of just summing up everything. And again, that video will be in Schoology if you guys would like to watch it over again. Um, with that said, um, going back to that last quiz that I gave you guys, there was a quiz that I gave you guys on Friday, February the 12th. It's interesting that the grades on that quiz was kind of all over the place. I had students to do really really good, and I had some students to do not so good. But what I want to do is those questions on the quiz that involve conduction, convection, and radiation. I briefly want to go over those questions for you guys so that you guys recognize these examples when you see them. When it says, what heat transfer takes place when you cook a casserole in the oven? Well, it should be obvious here that this is convection, because think about it, guys. If you put a casserole in the oven, the casserole isn't directly touching the flames, so it's not conduction, right? So it's basically the reason why the casserole is going to get heated up, because in the oven you have all these air molecules, and these air molecules, as they're being heated up from the flame below, they're creating a convection current where the warm air rises and the cold air sinks, and that happens until the molecules are evenly distributed throughout your food, until the heat is evenly distributed, I should say. So just something to keep in mind. This question right here, where it says, what heat transfer takes place when lizards lay in the sun to warm up? Well, in this case, it's radiation, because the lizard is directly receiving electromagnetic waves from the sun. Okay, so anytime you see the sun, and the sun is primarily it's the primary method that you're getting the energy, know that is radiation. That is radiation. Come in.
AT,
Yes, sir.
use the fire extinguisher here for a demo.
Okay.
Just let you know it's in my room if you need it.
All right. Yeah. Right here says, what heat transfer takes place when you cook a hamburger meat in a skillet? Okay, so in the case of cooking on the skillet, so in this case right here, the hamburger meat is touching the skillet, which is touching the flames. So this is being heated up through conduction, because the heat is touching the hamburger, and the energy flows into the hamburger patty from the hotter substance to the colder substance until that heat is evenly distributed, and the temperature of your hamburger is the same as the temperature of the skillet. So this is through conduction. Okay. Again, I just wanted to go over those with you guys, because like I said, according to the grade, some of you guys didn't understand that, but I wanted to be sure I go over that. All right. Now, a couple of more things I want to talk about before we're done for the day. I want to talk about impulse and momentum, because there's going to be a lot of mathematical questions on the test involving impulse and momentum. Let me share my screen. In fact, guys, before you guys take the test, I would highly recommend that you guys go back and look over these two videos right here. The first video from January the 25th. This is when we introduced momentum, right? We talked about what momentum is. Momentum is the quantity of motion is mass times velocity. But the most important video to look over is this right here, the physics class from January the 27th. And of course, the reason why this video right here is important because on this day we did a lot of mathematical problems involving momentum and impulse. Okay, so definitely look over this video from January 27th. Notice how I did those calculations, how I did those problems, because on this test, I would say most of the questions on this test involve calculations. Most of the questions on this test involve calculations. Also, let me say this here. So let me write down some equations that I want to give you guys. So on this test, okay. So remember, in the impulse momentum unit, I gave you guys two main equations. I gave you guys the equation for momentum. And remember that momentum is equal to mass times velocity. I also gave you guys an equation for impulse. And impulse is equal to force multiplied by time. In other words, change in time, or your time interval. Okay. So guys, these are going to be the two main equations that you're going to be using for the momentum impulse problems. Okay. Now, guys, on some of the questions, whenever it asks you to calculate impulse, look closely at what they give you. If they give you force and time, you can easily multiply those to find impulse. Now, sometimes, guys, in some of the problems, it may give you extra information that you don't need. If it gives you extra information, don't worry about that. If you see force and time, all you know to multiply those together to get impulse. For example, in some of the problems, it may give you force, time, and it may also give you mass. If it gives you any additional things that you don't need, don't worry about those additional things. If you have force and time, you can find impulse. Okay. And also, remember we talked about the impulse momentum theorem. And I know this was a while back when we went over this, so I'm just briefly going over it, but I really want you guys to go back and watch that video if you need to. So if you guys remember, we went over the impulse momentum theorem where we said that the impulse acting on an object is equal to the change in momentum of that object. So in other words, guys, one thing just so happens to equal the other. So impulse we know is force multiplied by time, and then change in momentum is mass times change in velocity. Okay. So guys, on these problems here, look closely at what they give you. Depending on the problem, sometimes on a problem they may ask you, okay, find the object's change in momentum, but they give you force and time. Guys, if they on the test, if they ask you to calculate change in momentum and they give you force and time and any additional information, all you need to do is multiply force and time by each other to find impulse, because if you know the impulse, then you know the change in momentum, because those two numerical numbers equal each other. Okay, so just something I want to give want you guys to keep in mind. So there's two ways you can find change in momentum. You can find it either by multiplying mass times change in velocity, that's one way, or you can find it by multiplying force times change in time. Just look at what they give you guys in the problem. Okay, so this is just something I really do need for you guys to keep in mind on the test. Okay. Let me see. What else did I have for you all? Okay. But yeah, guys, really go over this video with these calculations here. Also, guys, go over this video right here from February the 3rd. And the reason why I want you guys to go over this video because um, whenever it comes to calculating, heat energy, there's going to be a few questions on the test right here that involves using this equation right here. Q equals mass times specific heat capacity times change in energy. So you're going to use this equation a lot on the test as well. So be sure you know how to use this equation here. Be sure you know what each term means. Basically, all the questions that we worked out from this particular class period, right here, if y'all remember, we worked out these 5 questions in class together. If you guys know how to do all 5 of these questions, any questions that I give you on the test involving specific heat, you should know how to do just by understanding these 5 questions. So I'll write this down to go over this video as well. Physics class on February the 3rd, because again, there's going to be a lot of questions on the test involving this specific heat equation. Okay. Now, the very last thing that I want to go over is entropy. We talked about this on Monday. Oh, guys, I'm looking for that thing that I wrote down. Okay. Okay, guys. On the test, there's a few questions involving. Come on. Hold on, guys. Let me get this back on. Okay. On the test, there's a few questions involving the second law of thermodynamics. And remember what the second law of thermodynamics says. The second law of thermodynamics, which is the law of entropy, says that the entropy of an isolated system increases over time. I'm going to say that again. The entropy of an isolated system increases over time. Remember what entropy is. Entropy is a measurement of disorder. It's a measurement of randomness. Okay. So things become more random and more chaotic over time because of the second law of thermodynamics. So just remember that entropy increases over time. If you take an object or take a system, and again, if you guarantee it's a closed system, you can always guarantee that as that system just proceeds naturally, then it's going to become more disorder or more random over time. You don't see anything in nature where that process will reverse itself. So, for example, have anybody ever seen an egg unbreak itself? Has anybody in here ever seen a shattered egg put itself back together where it becomes more ordered over time? No, you don't see that. No, y'all have never seen that before. Not in the real world. So y'all have never seen that before. Because if you were to see something like that before, that would violate the second law of thermodynamics. That just doesn't happen. The second law of thermodynamics says is that systems tend to become more disordered over time. They become more random. They become more chaotic. Okay, so particles tend to move all over the place and become scattered. Okay, now. Now, some of you guys in your mind, if you can think of an example that would violate the second law of thermodynamics, let me explain to you guys very clearly why that does not violate the second law of thermodynamics. And y'all remember I gave this example last class period. So for example, imagine you taking a cup of water and you put it in the freezer. And over time, that water will eventually freeze and form ice crystals, right? Because ice is a highly ordered structure, right? So those water molecules are slowing down and they're kind of like, snapping together in place to form these ice crystals. So this process right here will appear to violate the second law of thermodynamics, because it appears that, we have something here that is becoming more ordered over time. Okay, but guys, the important thing I want you guys to know here, this does not violate the second law of thermodynamics, because the second law of thermodynamics only applies for closed systems. In fact, I'm going to write that down. The second law of thermodynamics only applies for closed systems. In this case right here, in the case of dealing with the cup of water, we are not dealing with a closed system here. In fact, our cup of water is an open system. How do I know that it's an open system? Well, because remember, when you turn the freezer on, the freezer pulls energy out of the water. So because the freezer allows energy to come out of the water, you can guarantee that you are dealing with an open system, right? And we're going to see this here. So I'm playing the video. Okay, so right, so we see it here. So as the freezer is on long enough and the cup of water is in the freezer for a while, all of this energy gets pulled out of the cup of water and it causes ice to form. So because this is an open system, this does not violate the second law of thermodynamics, because the second law of thermodynamics applies to closed systems. All closed systems tend to proceed toward disorder with time. Okay. Any questions? Any questions? Okay, now, if you guys notice, I did not give you guys an assignment to do today to turn in. The reason being is because I want you guys to use this time to look over the information for the test. The review sheet for the 4 to 6 weeks test is currently in Schoology. Guys, this is not required that you do this. It's just something that's optional. Basically, I put there are 48 questions on this review sheet. Go over it. Go over the things you think you need help on. And again, I'm gonna leave the rest of the day to you. I'm gonna leave the rest of the day for you guys to work on this as you choose. Okay, I'm gonna keep the Zoom call open up to 9:10 in case any of you guys have any questions for me while you are working on the review sheet. Again, this is optional. You don't have to do this, but it's something that I'll recommend that you do. Okay. If there are no immediate questions for me, you guys are free to go. Remember, don't forget to log into Eduphoria on Friday to take your test. Have a good one, everyone. And for those of you guys who need the attendance form, I'm going to put it in the chat box again. For those of you guys that need that. All right, guys, have a good one. And this video will be posted on YouTube.